Question 2 on the quiz involves a pipe with a porous mesh filter in it. And we don't really know anything about porous mesh filters other than this one happens to be in the pipe in the way. The fluid's water at 20 degrees C, so we know it's got a density of about 1,000 kilograms per cubic meter. And the manometer fluid, this stuff down here, has a considerably higher density, 1,900 kilograms per cubic meter. The inside diameter of the manometer is 5 millimeters and the elevations are as shown on here, and the flow is steady. Now that 5 millimeter inside diameter is something you really don't need, but it doesn't do any harm to know it. The next question is, what's the pressure difference between locations A and B in the diagram, each located right at the points where the manometer joins the pipe? So there's location A, there's location B, and to do that we'll do a static pressure calculation around the manometer. If we've got steady flow, we expect no motion in here. And so starting from point B to get to point A, the pressure at A will be whatever the pressure was at B plus the density of water times G times 0.25 plus the density of the manometer fluid times G times 0.4, no change over to there, minus the density of water times G times 0.4 minus the density of water times G times 0.6. So that gets us around the loop from B over to A, doing the stepwise static calculations along the way. And if we plug that in, we wind up that the pressure at A is the pressure at B plus 112.7 pascals. So 112.7 pascals is not a very big pressure difference, but it is some pressure difference, and it is a higher pressure at A. The next part of the question asks, which way is the water flowing through the mesh? Circle one option and explain why. Well, the pressure is higher here, and the elevation is higher here. So water flows downhill, water flows from high pressures to low pressures. Both of those exert a force in the direction going from A to B. So to get full marks on this question, you really have to pick up that both of those characteristics are true. If this pressure was lower than that pressure, the flow might still be going in this direction. If that pressure difference was still smaller than the difference you'd expect due to the change in elevation. But it's pretty straightforward because both the pressure and the elevation are pointing in the direction from A to B for the flow.